The incident in question took place at a bowling alley and arcade. One of the patrons of the arcade was attempting to use a punching bag machine. In the process of using this machine, he had ended up punching the machine adjacent to the punching bag machine, and there was a question as to how exactly this happened. The machine next to the punching bag machine was a prize machine, so on the left side of the machine there's a big glass opening, and then on the right side there were glass boxes representing prizes that you could win, and one of those glass boxes had been broken by the plaintiff's hand in this case. First off, the question was how far away was the adjacent machine from the punching bag machine, and we had to determine this without having the two machines in the position that they originally were in. So we have photographs representing the positions of the machines on the day of the incident, and then from those photographs had to determine, okay, what was the relative orientation based on inspections performed after the day. The field work actually involved 3 individual inspections. Going to the site, we immediately discovered that things had been moved from the day of the incident, so we needed to document everything thoroughly, and the prize machine that had been a component of this case was actually in a different facility. So we had to go to the second facility, scan the prize machine, and now that we have the scan of the prize machine, the scan of the punching bag machine, and a scan of the scene, we can kind of put all the pieces together. So the initial component of the analysis was geometrically, how did all these machines lay out? What was the distance between the two machines? In order to answer this question, what we did was utilize a technique called camera matching photogrammetry. So you can take the photograph, within the photograph and within the scene data, there are matching points that you can utilize. So in this particular case, there was a doorway in the photograph. We can take the doorway in the photograph and shift the scan data so it overlays exactly where the doorway in the photograph was, so that way everything starts to line up. And then you can essentially move all the individual components within the scene so that they line up exactly with how they're depicted in the photograph. Once the client got that knowledge, they wanted to determine, okay, we know how everything was laid out. Would a person who is the height and weight of the plaintiff, had they been utilizing this machine as it is designed, within a reasonable degree of engineering certainty, was there any mechanism for them to make contact with that prize machine? We used a motion capture suit, and we used a relatively newer technology which involves a markerless motion capture technology. So we had 2 independent motion capture analysis techniques, one involving our surrogate wearing a suit with various markers on it that we can track, another using 3 cameras to independently track his motion and then stitch together his position in 3D space. In our series of tests that we conducted with the surrogate, we had him punch the bag in accordance with plaintiff's testimony, and then we had him punch the bag, essentially as if he was just trying to achieve the highest score possible. And that involved punching the bag squarely on, and also in this case, the plaintiff was punching, he was right-handed, and the machine that he struck was positioned about 4 feet to the left of the punching bag machine. In order to maximize that likelihood to provide the most conservative analysis, we instructed the surrogate to punch the right side of the bag as hard as he could, and we wanted to see how that would affect his post-impact travel to his right hand. And what we saw was there was very minimal travel after striking the punching bag. This punching bag absorbed a lot of energy, and there was less than a foot of post-impact hand travel. So even though you have someone punching the bag as hard as they can from the right side, you're coming nowhere near that adjacent machine. So the likelihood that someone would punch the punching bag and then follow through and strike the adjacent machine is incredibly unlikely. This was a physics-based analysis, and the ultimate goal was determining how everything laid out in 3-dimensional space. When someone is punching a punching bag who is 6'2" and 225 pounds, what does their motion look like? How much are they moving their limbs? How much do they move to the left when they're punching a punching bag with full force? You know, these questions really can't be answered unless you have this combination of motion capture technology and the 3D reconstruction visualization capabilities. The ultimate opinion in this matter was that had the plaintiff been utilizing this machine as it was designed, there would have been no mechanism for him to make contact between his right hand and the adjacent machine, much less with sufficient force to cause fracturing of his hand.